So what we're looking at today is maximum and minimums again, but it's important for us to remember that, like, although I've asked you to do the quadratic, or not the quadratic, the completing the square process, this is an alternative to that. Okay, and we like this process because it's faster. It's way faster. We're talking about, like, efficiency of getting to what it is I'm looking for. This is also not going to work if you're not listening. That was also maybe some, well, I don't know what you would have listened to yesterday because I wasn't really putting down anything decent, but you have to listen. Okay. So, just like what we saw in the last unit, okay, we can evaluate a function for any value of x and get a corresponding y as an output. Is everybody okay with that? We input a value of x and get out a y. We also learned that the opposite was true, okay? So with the partial factoring, that's what we're going to put in here. Okay, with the partial factoring, we use this idea, but except rather than inputting a value of x, we're going to input a value of y, okay? So we're going to replace the function notation f of x with some number and then solve for x. We're doing the exact opposite of input and output. We're going output, find the input. That's what we're doing, okay? So for quadratics, however, okay, I think in the last unit we saw all sorts of functions. But in this, like with quadratics, we expect to see for one particular value of y, we can have two values of x. Okay, there can be two spots on the graph that have the same y value. Okay? And so what we're doing today is using that fact where we know one of the x values, we're going to try and find the second one that corresponds with that y value. Is everybody okay? The picture will also help us today, I think, with the representation of that. Okay? Because of the axis of symmetry, that's because of the axis of symmetry in the parabola, right? So we get this kind of mirrored effect with the parabola. And so we can find some points with the same y values, okay? So for example, the quadratic aside has many points that share the same y value but different x values, okay? So let's name a few. Okay, what are we seeing? Some example, yeah, so
3.
Okay, so is that a point?
Oh, 0 and 3.
Okay, 0, 3 is a good one. Okay, so I have 0, 3. Now, what's another point with a y value of 0, or sorry, with a y value of 3? On that graph, Ben? Negative 2 and 3. Negative 2 and 3. Okay, is there another one we could find? Not with like a different y values now. Let's find different y values. Sophie?
1 and 0.
1 and 0. Where's another point on the graph with a y value of 0? Yeah, negative 3 and 0. Okay, let's find two more. Two more, I think I'll bring your attention down here. Gabe? Negative 4, negative 5. There's one. What's the mirrored image of negative 4, negative 5? That's right, buddy. That's right. Okay. Okay, all of those share what in common? We have 6 points there. They all have one thing in common. Yeah, okay, sorry. So 3 of, yes. No, he's right. That wasn't necessarily the best worded question. 3 pair, like, of the pairs there, the 3 pairs of points that we have identified there have one thing in common. That's a better question. What's that one thing in common? Gabe? So just look at the points that are identified on that graph right now. Okay, there's Ricky?
Each pair has the same y value?
Each pair has the same y value. And then what's I'm just gonna tell you because I can't come up with a great. I'm trying. You're not getting it. Like I think it's relatively straightforward, but they all have an axis of symmetry in the middle. Each pair has the same amount of distance in the x direction from that red line. Would everyone agree? That red line is what we define as what? As a name. It's the axis of symmetry. Okay, so if I can use that to my advantage here. That's all I'm doing with this. Okay, so what I'm going to do is I'm going to take that parabola that I have there. I'm going to partial factor it and solve for the equation of the axis of symmetry so that I could use it to find the vertex. That's all I was trying to do yesterday. Okay, and then we can use that process to help us answer the word problems in a much faster way than completing the square, I think. Okay, because the completing a square process can get bogged down. It's a little bit more difficult to make a mistake in this process. There's just less work to do, that's all. Okay, so it's a little bit more reliable. Okay, so what I'm doing is I'm going to find the axis of symmetry for the quadratic using one of those 3 points. Typically, the one we will use will be the pair of points that has the y-intercept on it. Okay, what I'm gonna do, because there's the y-intercept. Everyone agree? Okay, I'm gonna look for that point. And there's something shared between those 2 points. The thing that's shared is the fact that their y values are 3. So what I'm gonna do is I'm gonna replace the function notation. I'm looking for the value of x when the graph is 3. Everyone in agreement? So what I'm gonna do is I'm gonna replace f of x with the value of 3 and solve for the x values that make that true. That's what's happening. Okay, I'm gonna write a little sentence here. Maybe that'll help with the explanation. Okay, we're gonna say find okay, we already know one. I mean, if we didn't have the picture, we wouldn't know the second one already, but we would know one for sure. The one we would know would be that y-intercept, right? It would be 0, 3. Okay, our job is find the other one. Okay, so that's what we're going to do. We're going to replace f of x with 3. The value of the function is 3. And I'm looking for the x values that make that true. How did I know it's 3? I basically want that to disappear so that I can partial factor it. Okay, so I'm just going to go, okay, how do I solve for x? That's all I'm going to do. Well, I can't solve for x unless I have 0 on the one side, like it's equal to, unless the trinomial is equal to 0. Okay, so that's what I'm going to do. I'm going to take 3 away from both sides. And I'm going to be left with 0 is equal to, because 3 minus 3 is 0. Is everyone okay? I think the use of the picture's a bit better today. Okay, so I'm looking for the 2 values of x. We know 1, so now I'm going to factor this, partial factor. Okay, that means negative x is equal to 0 and x plus 2 equals 0. Okay, so x is equal to 0. We already knew that one. That's the point 0, 3. What I'm looking for is the other point that has a y value of 3. Its x value is x is equal to negative 2. So its point is negative 2, 3. Is everyone okay with what's happened? If we didn't have the picture, it's the exact same process. So we already kind of knew what our answer is supposed to be because we had the picture. You're not going to have the picture on the test, right? Or when you're solving a word problem, right? But you are going to be able to identify from the equation what the y-intercept is. Okay, that y-intercept is right here. It's the c value, which is what we were trying to communicate yesterday. We just had that graph yesterday, just had a bunch of variables on it, which was making it a little bit difficult to decipher. Okay, so now if I'm interested in finding the vertex, what if I just kind of, I haven't found x-intercepts per se, but I found 2 points that are at the same height on the graph. Dylan? Yeah, so we can find the axis of symmetry by taking the 2 points that are at the same height, adding their x values together and dividing by 2, right? So I could take 0 plus negative 2 divided by 2. What's negative 2 divided by 2, which is negative 1? The axis of symmetry, the equation of the axis of symmetry, is going to be x equals negative 1. Does that or does that not check out with what's on our graph right now? I think it does. Okay, so that's the axis of symmetry. That's what we found. We're done with part A. Okay, just like last year now, once you found the axis of symmetry, I know, because I can see it, the axis of symmetry is the x portion of the vertex, right here. So what do I do when I have an x value and I'm looking for a y value and I have a function? What do I do? This is exactly like Unit 1. Gabe? You input the x value into the function. It spits out the y value. Aha, we get the vertex. We get a point, okay, on the graph. So that's what we're going to do. We're going to evaluate the function at negative 1. When we evaluate, we get negative 1 squared minus 2 times negative 1 plus 3. So f at negative 1 is going to equal Gabe? Be careful. I'm assuming, without Gabe saying anything, and not just Gabe, a few of us are going to probably make this mistake here. It's negative 1 squared times negative 1. Negative 1 squared is positive 1 times negative 1 is negative 1. Okay? I didn't say anything, but I almost guarantee some of us are going to make that mistake. Okay? Once you get the hang of this, I do think it's faster than completing the square. Depending on how good you are at completing the square. Okay? And when there's fractions in front, and you have to, what's the one thing we can't do with completing the square? Or what's the one thing we have to deal with before we do completing the square? The a value has to be 1, which causes some fractional work, which causes some complications in our completing the square stuff. This is nice because I don't have to worry about that. Just partial factor and solve for x. That's it. This is nice that way. Okay? So, use partial factoring to solve for the vertex of the function and state the domain range. Okay? So first things first, we're going to look for, we're looking for the axis of symmetry. And then the second step is sub AOS into equation to get y value okay. So we know in part A there, we know one of the point, what's a point on that graph? Right away, Dylan? 0.17 is a point on that graph. Okay, we know that the y-intercept is 0.17. So what I'm looking for is some other x value, I don't know what it is, that shares a y value of 17. So what I'm going to do is I'm going to replace f of x with 17, and I'm going to look for the x values that make that true. What inputs need to go in to give me an output of 17? That's all that's happening here. Okay? So we're going to say 17 is going to replace the function notation. Okay, so x can equal 0 and x minus 6 can equal 0, or x is equal to 6. Okay, we already knew that x equals 0, checked out. X equals 6 is that second number I'm looking for. Okay. So, I'm going to find the axis of symmetry now. It's found by going 0 plus 6 divided by 2, which is 3 over 2. Sorry, 6 over 3. 6 over 2. So there's the equation of your axis of symmetry. Okay, and now what I'm going to do is evaluate the function and find a y value given that I input a value of x. It's going to spit out the y that corresponds with that value of x. In this case, it's a special point. It's our vertex. Okay, so I'm going to evaluate the function at f at 3, which is going to equal 3 squared minus 6 times 3 plus 17. So, in conclusion, I'm going to go up here. The vertex is 3, 8. Okay. The parabola is opening up. Well, I'll let everybody get caught up. Just right for a sec. Okay, I'll let everybody. This is an important part. Okay, are we okay? So, direction of opening, up or down? Up. Everybody say up. Because It was more of a question, not a demand. Like I didn't need to hear. It wasn't like
Said everybody's oh.
yeah, I get the confusion. I was just clarifying what happened. That's all. It wasn't really like speaking to a group of dogs and saying speak and then go hearing like 40 barks. Like I just I was more of a is everybody saying up, and then we heard like 3 or 4 ups. Okay. It is opening up because the A value is positive. So, the A value is positive, and the vertex is above the x-axis. Everyone agree? Where's the vertex right now? 3, 8. I don't care. It's over here somewhere. And it's opening up. So its domain range is what? If this is 8. Gabe?
X is
Yeah, x can be all the real numbers. And so somebody write this down, Sophie. And what is y?
Y is a part of the real numbers such that y is greater than or equal to 8.
Y is greater than or equal to 8. Okay? Are there any solutions for that quadratic? Any roots? What do I mean by roots or solutions? That's what we're going to concentrate on tomorrow. And we've already done a little bit of it now, or before, with the completing the square, but see x-intercepts. Is that ever going to have x-intercepts? No. What happens in that scenario? What do you expect? If you were to try and do the quadratic equation on that, what are you going to get? You're going to get a negative number underneath the square root. Now, no answers there. You break it. Can't square root negative numbers. Okay? We'll go through the next one, and then we'll try some word problems, and then you guys have some time to work today. Hopefully get you some stuff, okay? Okay. 0, 11 is a point on the graph. I'm looking for the other number. Let's go through this one. I think this is I think you're going to like this. Despite how yesterday went, I think you're going to like this as time goes on over doing the completing the square process. That's quite quick. It's the same thing over and over. You don't need to show me the explanation anymore. You can just set it equal to 0 and get rid of the y-intercept because we know what we're doing. Right? We're looking for that other x value that gives us the y-intercept value of 11 in this particular instance. On?
What if we're not solving for the y-intercept?
Well, that's, I think, like it could have been, as we saw in the first question, it could be any number of points that have the same y values. That y-intercept's that's the one that's readily available to you right off the bat, right? So it'd be a little difficult for you to find those other points. Like I don't think you can do it without, you have to use the 11 or whatever the C value is to do it, right? Yeah, but what are we trying to, okay, to Bryce's point, Bryce is saying factor it, solve for the roots. That might not be factorable. Factor it, solve for the roots, find the middle of the roots, substitute the middle into the equation to get the vertex. That's what you did in grade 10. You've done that before. That was a lot of words coming out of my mouth, which means a lot of work for you. This is, look how many, like, that's 3 lines. Like 4 lines, I'm at my answer. Now I can find the middle, right? Imagine if that was the quadratic equation, which 2 numbers that multiply to 33 and add to -6. Like, I don't know if you can do that or not. So you're using the quadratic equation. That's a lot of steps. Okay, axis of symmetry. This is a nice alternative. Okay, so the vertex is 1, 8. Opening up or down? Up. Which makes the domain is always for a quadratic XER. The range, though, same as last time, unfortunately. It's not one thing I didn't do well today. Just give you a range that's different. Are we okay? I kind of like this. As painful as yesterday was, I kind of like this more than completing the square. It doesn't change the fact, though, if I ask you to solve something using the completing the square process on a test, you have to do that. If I just give you a word problem, I don't care what you do. Pick what you want to do. Right? Or do I say solve for the roots using the completing the square process? Because we spent a bunch of time on that. You have to do that. But the word problems, I don't care. Do what you want for that. Okay? You do it the quick way like this, like what I'm about to show you, or the slow way. Is that okay? Or quadratic formula, whatever. We'll do that tomorrow. We'll clean up. I think we'll do a broad sweep of quadratics and then move in where we are going to apply the quadratics now. Specifically the factoring. Okay, is it okay? I think we did do one of these questions yesterday. We just kind of slammed it in at the end of class. Okay, this is the same thing. We have a function, partial factor of the function, solve for the those two x values that are at the same y value, find the middle, substitute the middle in, you get all your information here. It's the exact same thing, we just have words on top now. Okay, so the height in meters of a rocket fired into the air after t seconds can be modeled by the function h of t is equal to negative 3t squared plus 30t plus 73. What is the time needed for the rocket to reach its maximum height? Find the axis of symmetry. Okay, I'm going to go h of t is 73. I'm going to get 73 is equal to negative 3t squared plus 30t plus 73. So 0 equals okay. So that tells us the other t value where the rocket, like basically what's happened with the rocket has gone up, it's reached some maximum height, and then it's began descending again. And somewhere in the middle it reached the maximum height, right? Or shortly after it reached its maximum height, it reached a y value of 73 meters again. Okay, so in a picture representation, it would look something like this, right? We got fired from a cliff. It went up. The cliff is 73 meters. The rocket got fired, it went up and then came back down. So there was that point at 73 meters, and somewhere, sometime, well, I found what the time was. 10 seconds later, the rocket hit 73 meters again. Everybody following now? I think the words maybe put a little bit of context on it, right? Like what you fire up, it has to go up, and then it has to come back down again because of gravity. So if we fired it from 73 meters, it went up, it would have somewhere in the middle of these two values reached the maximum height, which is ultimately what I'm going to find out in part B. Part A is asking me, how long did it take the rocket to reach its maximum height? That's 5 seconds. How do we prove that algebraically? Well, we'd go the axis of symmetry is that 0 plus 10 divided by 2. Okay, I can solve for the max height by taking my function and evaluating it at any value of x. I just have one in particular where the maximum height occurred at 5 seconds. So I'm going to evaluate my function at h of 5. Everybody okay? Good, good, good. Bryce? It's just like, it's just every, so here, Bryce has a good question. And there's this duality to quadratics that I think maybe kids have confusion with, which is this question. Because we've seen instances where the quadratic equation doesn't work. Why doesn't the quadratic equation always work? Dylan? You can't square root negative numbers. So those instances, the quadratic equation gives you x-intercepts. But there exist quadratics that don't have x-intercepts. Everyone agree? On the flip side, every single quadratic ever will have a vertex. Everyone in agreement? And so the completing the square process works all the time. All the time. Because every quadratic has a vertex. And on the other side of the coin, this should always work too. Because what are we finding? Vertices. We're finding the vertex of quadratics. So this should, in theory, always work as well. There should be no limitations to this. Every quadratic will also cross the y-axis at some point. So you know there's going to be somewhere on that graph you can identify what the y-intercept is. Because it crosses somewhere. It has to be there. unless it goes through 0, in which that would be a unique instance where there wouldn't be a y-intercept there, but you would know what the y-intercept is. Be it 0. 0, 0, the origin. Okay? So this always works to answer that question. Are we okay? Let's go down. Okay? What's great about this lesson and the concentration around the axis of symmetry is that it translates into a question like this that we would have maybe last year done with the completing the square process. Okay? So what we're going to do here, how do we, remind me, we went over this yesterday. I think this part was okay yesterday. Revenue is equal to what? Yeah, the number of something you sell multiplied by how much you sell it for. Always and forever. Okay, what I'm going to say if we read this question, last year a banquet hall charged $30 per person and 60 people attended the hockey banquet dinner. This year the hall's manager has said that for every 10 extra people that attend the banquet, they will decrease the price by $1.50 per person. What size group will maximize the profit for the hall this year, and what would the maximum profit be? Okay, that is the x portion of your vertex as well as the y portion of your vertex, right? If I was producing a graph, it would have on the x-axis, it would have the number of people, and on the y-axis, it would have money. Okay? So what we want to find out is based on the conditions that they're imposing on us, or that they're saying, I'm going to say let x represent the number of $1.50 price decreases. Okay? These questions get set up, you see these revenue questions, they're like it's a number and something. It doesn't matter if it's whatever it is. There's lots of questions in homework. Okay? Tickets to a bus, like a bus company, like figuring out like what to charge for a ticket to maximize revenue. Banquet halls, whatever. Okay? So the number, how many people attended last year? 60. How does that change? We're going to add 10 people for what? Is it just 60 plus 10?
To the variable
X. It has to be 60 plus 10. X, yeah. Okay. Every time I decrease every time I add 10 people, the price goes down by X. That one fact, that $1.50, it goes down. Right, which we've already included in our let statement. So it's plus 10x. What about the money portion? What are we charging right now? $30. How's that changing? Owen?
Minus 1.5x.
It's minus 1.5 times the number of times you decrease by that 1.5, which is x. It's minus 1.5x. Now, yesterday we alluded to the idea that, sorry, I'll make it bigger. Last year we would have expanded, completed the square, found the vertex. We don't need to do that, right? This is the points on the graph where if I found the zeros, so if I set the revenue, because this would be 0 down here, revenue was 0 on my graph. If I set that little equation I just found equal to 0, I can solve for the x values that are at the same y value of 0. Solve for the middle. Substitute the middle in. Gives me my vertex. I'm looking for the axis of symmetry. It could be any number. It could be 1, 2, 3, 4. Like I could substitute whatever I want in here. Solve whatever. All that's saying is the y value is the same. I'm going to solve for the x values that give me that y value, and then I can find the middle. I like 0 because I don't have any extra work to do. Okay. Okay, so this means 60 plus x has to equal 0. Sorry, 60 plus 10x. And 30 minus 1.5x has to also equal 0. So 60 is equal to negative 10x. Okay, and 30 is equal to 1.5x. Okay, those would be the two number of price decreases or increases where the banquet hall makes no money. Okay, which is not what this question is asked, but we can use it to help us solve for the middle and ultimately what the maximum revenue would be with the number of people that it coincide with. Okay? So, if I find the axis of symmetry, that's your axis of symmetry. And what we could do is say, because the question's asking what group size would maximize the profit. So the number of people is going to equal, remember we already have an equation for this. It's the number of people. Okay, 130 people attending maximizes the revenue. How do we make money though? Let's reference the very beginning of this question. How many of something you sell? That would be 130 tickets you'd sell, multiplied by how much you sell them for. How much do we sell the tickets for? I don't know, but we have an equation to tell us that, right? It's this one. The money, how much we're charging for ticket. $30 minus 1.5 times 7. That's $19.50. So what's the maximum revenue? It's the number times how many people, like how much we're charging. So the 130 tickets multiplied by the 1950, which is equal to $2,535.